This is the summary for Lesson 5, solving any linear equation. And in general, what you're trying to do as you solve equations is you're trying to get the variable, the letter, on one side of the equal sign and the number that it's equal to on the other side. So you're going to end up with some letter, some variable equals some number. So the whole idea is to get this equation, for example, to fewer terms until you get to the point where you have t equals something. In this case, a way to do that is to add -5 to each side. So if you're adding 5, then to get rid of that 5, you can add its additive inverse, which is -5. This removes the positive 5. So it will leave us with 3t equals 2. So 7 plus a -5. So we're adding -5. So 7 plus -5 equals 2. And so then the next step is to get rid of this 3. This is the coefficient. So if I use the additive inverse here, to be consistent, I want to use the multiplicative inverse. I want to think about just addition and multiplication, the additive inverse, and the multiplicative inverse. So rather than dividing by 3, I'm going to multiply by 1/3. It is the same thing, but I'm being consistent in that I'm going to use the inverse of the values, the multiplicative inverse, and this is going to make the coefficient 1. So let's look at this in a little bit more detail. To get this coefficient to equal to 1, to find out what 1t or t equals, I'm going to multiply by the multiplicative inverse. What that means is if I have 3 t's, I want to know what 1/3 of those 3 t's equals. That's going to tell me what 1t equals. At the same time, I want to know what 1/3 of 2 equals, because then that t is going to equal 1/3 of 2. So again, if I have 3 things, what's 1/3 of those 3 things? And that's going to equal 1/3 of this 2. So 1/3 of 3t is 1t, and 1/3 of 2 is 2/3. So I put this in this order. I move this 2 out a little bit and slip this 1/3 in there because I want to think of it as 1/3 of 3t and 1/3 of 2. Most people would just put the 1/3 after the 2 and say 2 times 1/3. It's a different view. Think of what 1/3 of 2 is. Then think of what is 1/3 of 3, what's 1/3 of 4, what's 1/3 of 5, what's 1/3 of 6. Those are different than 2 times 1/3, 3 times 1/3, 4 times 1/3, 5 times 1/3. So just a different way of looking at it. You get the same answer, but in understanding, it's a deeper understanding if you think of it as 1/3 of this term is equal to 1/3 of this term. And so at the end, you get t equals 2/3. So here it is right here, t equals 2/3. Here's another equation. So what do you want to do in this case is get rid of this 4. So how do you get rid of that 4 is you multiply by the multiplicative inverse. You multiply by 1/4. That removes the 4 because 1/4 of 4 is 1. So I have 4 of these groups. What's one of those groups equal? It's 1/4 of those 4 groups. But then on the other side, you also have to calculate what 1/4 of 12 is. Well, 1/4 of 12 is 3. And you can check that by saying 12 divided by 4 is 3. So these are some of the steps that people follow in general. You're not always going to do all these steps. It depends on the problem. But to get used to this stuff, generally you start out with the distributive property. You want to get rid of any parentheses. There's a couple ways to do that. You can multiply all the way through by a denominator if you want, or you can use the distributive property. Then collect the terms that are alike. You're going to use the additive inverse to add things, to move all of the variables to one side, and then to move all of the numbers to the other side, you're also going to use the additive inverse. And then you're more than likely you'll be left with a term that has a coefficient, a number next to a variable. So in that case, you want to use the multiplicative inverse to get rid of that coefficient. So you end up with a variable is equal to some number. And I always like to change the subtraction to addition. That's the first step that I like to do, because I always want to think about addition and multiplication. So I change the subtraction to the addition of the additive inverse.